Hi, I'm Chung, and I'm excited to present our work on creativity support tools. We conducted a large-scale literature review on how technologies, roles, interactions, and users intersect to form a design space of art-making creativity support tools. This work was done in collaboration with Shiqing and my advisor, Eytan Adar. Creativity support tools, or CSTs, have become an integral part of artistic creation. They are powered by computing technologies, and these technologies has expanded which roles CSTs can serve. For instance, machine learning powered generative algorithms now can generate content without specific user input, like playing drum along the user who improvise on other instruments. Advances in technologies has also changed how these tools interact with the user. With our drum example, users no longer play drums by themselves, hence their interaction with the drum track would change. Technological advances in CSTs are also changing the range of users who can create. With our drum tool, we can open the doors to those without drumming expertise. So, we can see that there are many aspects of CSTs. While some of these have been investigated by previous work, our focus is how all these factors intersect to form the design space of art-making CSTs. We believe that investigating art-making CSTs with this perspective would allow us to identify existing design patterns and underexplored areas of art-making CSTs. With this motivation in mind, we analyze technologies, roles, interactions, and users of art-making CSTs by studying 111 publications on art-making CSTs. Here, we define the art-making CSTs as those support the creation of artifacts with aesthetic qualities. We focused on research systems as they include tools that are novel but not yet commercialized. Moreover, research systems accompany papers with detailed description on aspects of our interest. In our analysis, we also limit the scope of tools to those that support a single user. With our criteria, we sampled papers from those that are cited by previous literature review work, while sampling newer papers with the sampling approach used by the previous work. We also searched for work that is cited or citing the work that we already found, or those from recent HCI conferences. We coded 111 sampled papers with a combination of inductive and deductive approaches. For a detailed description of the sampling and coding approach, please refer to the paper. With the coding, we identified code for taxonomies of roles, interactions, technologies, and users. Due to time in this presentation, we focus on few codes. For more details, please take a look at our paper. For CST roles, we identified a taxonomy of resources roles and process roles. Resource roles signal which type of benefit the tool offers, whether they are about ideas or skills. In contrast, process roles categorize which part of the creation process the CST supports. Here, we explain a bit more details about process roles. One process role is execution assistance. These tools usually augment the user's action to implement the artifact. For example, in the case of digital brush, as it augments the user's action to create brush strokes, it would serve the role of execution assistance. Another process role is producing, which generates artifacts on behalf of the user. The aforementioned drum playing CST would fall in this category. The last process role we want to mention is critique, which gives feedback to the user so that they can improve the artifact. In interaction approaches, we found three dimensions. They are directness, predictability, and whether output is implementing or influencing. In the interest of time, let me focus on two specific dimensions. The first is directness of the input. Direct input is close to the artifact, like being the brush strokes on the canvas, or a part of an artifact, like vocal recordings in dubbed animations. Indirect input, on the other hand, is distance from the finer artifact. Examples of indirect input include natural language queries or parameters given to the tool. Another dimension of interaction approach is whether the tool is supporting by implementing or influencing. One example of an implementing tool includes aforementioned tools that generate content. Influencing tools, on the other hand, give information that can change the user's behavior, like feedback, scaffolds, critique, or analysis. For technologies, we identified a broad spectrum, but I'll focus on one type: learning algorithms. Learning algorithms are usually machine learning algorithms that are trained on data. They can be used to recognize patterns in artifacts, and recent ones can generate partial or whole content. For users, we identify taxonomies according to expertise and whether they are specific population that require special accommodations, like for children or those with disabilities. With our identified taxonomies, we found many interesting patterns. For some cases, patterns are inherent and natural. For example, CSTs coded as producing tools tend to implement artifacts as implied by the code. For some cases, patterns happen because a community focuses on a certain types of CSTs. For instance, many CSTs for users with disabilities focused on building tools that support with skills rather than ideation, while such ideation tools can be designed. For other cases, patterns are due to technical viability, and they are expected to change with technological advances. For example, critique tools tend to receive direct inputs, like artifacts themselves, to give feedback on how they can be improved. Indirect inputs, like comments and parameters, on the other hand, were relatively less complex and have not been subject to critiques. However, advanced machine learning generative algorithms can receive rich and complex natural language descriptions to generate content, which is indirect input, and they can also be a subject to critique. To summarize, we could identify design patterns of art-making CSTs and how they can be expanded by looking into underexplored and not yet technically viable patterns. With our analysis, we also could identify those CSTs that were specifically powered by generative AI algorithms. We call these AI CSTs. While autonomous generation is technically doable to some, we identified that these CSTs are still designed to provide a high degree of controls to users. Hence, in process roles, more generative AI CSTs supported execution assistance rather than producing. At the same time, we could find that when AI CSTs support producing functions, they somewhat mimic human-human interactions. For example, a tool that serves the role of the actor in a comedy skit or interactive narrative assumes that these tools are used to replace human actors. Similarly, the drum accompanying tool also mimics interaction with human drum players, interacting through nonverbal cues. These tools are also common in that they mainly interact through generation, like by taking an action as a character or an actor, or by continuously playing drum along with the users. We would be able to expect that these types of more autonomous AI CSTs would be more visible with more technological advances. There are other interesting patterns between technologies, roles, interactions, and users of art-making CSTs in our paper. For example, we found critique tools tend to receive direct inputs while being unpredictable and influencing. For more details, we again refer you to our paper. In this work, we explore the intersections of roles, interactions, technologies, and users of art-making CSTs to learn the design space and underexplored area of research. Thank you for listening.